separated, and by separating their differences, the significance of what they're doing is more obvious. In the sense, the obvious difference between red, blue, and purple. Alright, anyway. Two kinds of force, two kinds of matter, two kinds of interaction. That's all you really need to know. And it does answer, it does create mechanisms that make everything else easily understood. Alright, so the force, the little stuff moving the speed of light that's filling the universe, if you organize that force, that is, you create a material mechanism, an atom, electrons and protons moving, you can create that force at a frequency, in the sense that you can move something from one position to another position and change what gets reflected off that electron or proton. So if I change their place in space at a regular rate, I will change what the pressure is doing when it's reflecting off of it, in the sense that the pressure, the distances will be shorter, right? I mean, hitting here is going to be shorter than hitting here. It's going to be a difference in time of my reflection, and that is essentially what creates frequency in terms of how the force is reflecting off an object. And by creating frequency, you create the electromagnetic spectrum of force. And just as it's created by very specific kinds of movement, it also generates the same kind of specific movement in matter bits, regular movements that have a consistency to their frequency, in the sense that there'll be rules of harmonics, like this motion will be twice as much as this motion, so both of them will complement each other, because both will allow things to hit the surfaces, or hit the pressure they're moving into at the same time. And so those will be constructive interactions versus non-constructive, versus colliding into each other and neutralizing any of the material differences between them. Okay. Let's see, no force, wave interference, just constructive reconstruction. So, without going heavily into the waves, are an emergent function. There's something a group of particles do. It says that group behavior equals wave. Single soldiers don't wave, but a whole bunch of soldiers can create a wave. That's simple idea. And so when we see something we are identifying as a wave, it's made out of discrete individual interactions that aren't waves. They're just a mechanical function. And those functions are the ones that can create a... You can, in a sense, when you're dependent on a certain amount of stuff moving at a certain regular interval of time, you can shift the time. You can take things and put them, they can be in alignment, and everything's cool in the sense that they're all hitting something at the same time and maximizing their impact. Or you can take them out of phase, that is, you can misalign them, and now you're not going to have the same impact in terms of the ability to transfer momentum, because the object you're hitting has time to relax, and because it's in pressure, and so you'll lose the effect of, the effects will be different when they're in phase. And so the basic idea is you can break the phase, and then you can reconstruct it. That is, you can put something out of phase, change its alignment, and then if you change it 180 degrees, 360 degrees, for sure, then you're back on phase, you're back in alignment. Even though you might be out of sequence, you're still aligned, and the alignment is what creates consequences in the real physical world. So those are the ones we measure and we see. And so there's no real destructive interference, because all you're doing is restoring balance. You're taking two things, something that's been absorbed more energy in this direction than that direction, so it's moving this way, and you can take something doing exactly the opposite, and the two will interact, and the two imbalances will create an equal sign. They'll create one on this side, and balance the two, a positive one, a negative one, and it'll become zero again. But you didn't really destroy the energy. You set it free in the sense that you restored it back to the universe. Now the universe itself is back to being balanced. So nothing's really destroyed. You're just taking stuff that is making something move, which means it's absorbed it, it possesses it. It possesses an imbalance. If something's moving relative to you, it means its balance relative to you is different than your balance. And you can restore its balance by imposing the opposite force, a force in the opposite direction. But you won't, and the restoration will give back to the universe energy going in both directions. So that too will restore its balance. All right. What else to say? The key to understanding energy conservation is understanding that energy is exchanged, not merely reflected or absorbed. So we might as well use the the boat analogy. That the electron is really energy trapped, and there's a certain amount of it. That's its mass. And whether we can measure that correctly or not is an open question in my opinion, but regardless, it has a mass of some kind in terms of it has momentum in all directions. The reason why you have a physical surface and a substance is because you basically are fighting the force, the pressure that's coming from the universe, and in the form of gravity, but it's really just the universe, the universal force. And your insides are repelling it in the sense that they're producing a force in the opposite direction, and that's why you have a shape and a form, is because there's a balance at the layer of your skin is where the balance exists, between the pressure out and the pressure pushing in. And that's how all things function, and it's the same is true for an electron. An electron is energy trapped, bouncing back and forth inside, say, a little, can be round, no rule against it, like a water droplet in space. The energy inside, if I poke it, the energy inside bounces back and forth. I would argue the same thing is happening inside of an electron. And the catch is as that thing starts to move, you can sort of understand that the amount of time the moving bits spend, the amount of time, momentum, or movement inside the water droplet, say if I moved a water droplet through space by poking it, that it would in fact spend more time, the water inside of it, moving in the direction that it's moving, and the bits inside would spend a lot more time moving in that direction than moving in the backward direction, in the reverse direction. And so the thing itself would likely just move through space by moving forward and stopping and then moving and then stopping and moving and stopping, because the momentum goes in. The initial momentum is never compensated for. You never undo it. And so that motion is forward. The reflection creates back to zero, no movement. Then it moves, reflects from that zero, and the reflection from that zero is going to create forward motion again. And so it goes from 0 to 50 miles an hour to 0 to 50 miles an hour based on the fact that the initial momentum went in a direction. And so that's always conserved. So there's an analogy of boats and an ocean to make it simple. Then there's these swimmers in the ocean that are moving the speed of light. And when they get in the boat, they replace some other rower. He becomes a swimmer, and the swimmer becomes the new rower. And they row as fast as they were swimming. It's just that when you put a bunch of rowers rowing in different directions, the boat won't go in one direction. It will go in the net direction of all of the energy that the rowers that are in the boat. So depending on which direction they're rowing, which was what direction they were swimming when they hit the boat, and that's essentially the force hitting the electron. And that's the direction the boat's going to go, is the net direction of what force it is interacted with in the last period of time that it takes to replace all the rowers in the boat. And that's all it's doing. So it's making exchanges, not it's substantially absorbing in the sense that the swimmer goes into the boat, but it's absorbing in a without gaining more explicit mass. So when they say something gains mass with velocity, they're really just measuring its mass in the direction it's moving. And what it really means is that it's exchanged mass going in the opposite direction. It doesn't weigh anything going in the opposite direction. Just as a helium balloon rising doesn't weigh on a scale in the opposite direction. You can't weigh it because it doesn't have any mass in the opposite direction that it's moving. So when mass increases, it's not total mass that increases. It's just mass in a direction that increases. All right, so that's enough of that. I can mess with the time dilation. I would just argue that the time dilation hasn't ever been proven as being anything else than a relationship between how fast you're moving an atom and how fast it decays. So the argument would be as if it's a multitasking argument, that when you have velocity, it means you're less likely to be affected by things moving in the same direction as you. That would be obvious. It's harder for something to hit me when I'm moving away from it. So there's lots of reasons to understand that any function of the atom that would be dependent on interactions in those directions would reduce its rate of decay. It's less vulnerable to the decay because the circumstance of two things hitting it at the same time in two opposite directions, for example, couldn't happen anymore, or wouldn't happen as regularly, depending on its velocity. So there can be lots of explanations for why. The fact is that when you do throw a wrench into space and it keeps moving, it's fundamentally changed from a wrench you didn't throw. So if I put two wrenches in space and I throw one and I don't throw the other, the two are physically different. The insides of them are arranged differently because of the movement. And it's that change that makes things things like predictable things, like the decay rate of an atomic material to change, is because the metabolism, the structure of the atoms, is actually being changed by the motion, and the change delays the processing of decay. And that explanation works. It satisfies the conditions, and you don't need any notion that there's some dimension out there called time that in some way can be manipulated. Time is just a function. It's used up by every time a little bit of the force moves at the speed of light, or every time there's an interaction using those little bits between two things in space. The time it took for all that to happen is used up. And it's quite regular, and there's no past that exists somewhere, and there's no future that exists somewhere. There's no dimension that they exist in. Time isn't a place. It's just a function. And it's a function that can that something can consequentially change how fast it does something, but it changing doesn't change the universe. So the whole idea of these frames where you can have special rules where you're changing the rest of the universe are fundamentally nonsensical. So anyway, I don't want to get into a bunch of that. I'm just saying there are explanations that are perfectly solid, that have to do with solid physics, solid object physics. You don't need to accept that it's, that you have to give space, which is supposed to be nothing, all kinds of complex properties to explain physics. There's rational physical explanations that will work and provide a perfectly satisfactory explanation for all the scientific evidence, all the experiments. Alright, so I guess we'll just show this quickly. So this is the simple understanding of the two interaction difference. that you would. The simple point is that